All right, so we're looking at 7.3 and 7.4. They really could have made it one section, but they decided to make them two, just adding and subtracting rational expressions. So whenever adding and subtracting fractions, you need your common denominators or like denominators. So if you have your common denominators, then you will go ahead and add and subtract accordingly. We have 2 over 7x cubed minus 9 over 7x cubed. 7x cubed is in our denominator, so we're good to go. And we'll do 2 minus 9, excuse me, which is negative 7. Don't forget to reduce if possible. We have 7s that can cancel. So it'll be a negative 1 over x cubed. All right, questions on that before we look at the next one? Here, once again, we have the common denominator that we need. So we can go ahead and combine our numerator accordingly. It's x minus 7 over x squared minus 3x minus 28. Then you do want to explore your denominator, make sure that it can, make sure to see if it can factor or not, and if one of the factors can cancel out with what's in the top. I can get that up. So this will factor out to give you x minus 7, x plus 4. So remember I told you that these rational expressions will lean on your ability to factor, so make sure you get your factoring skills straight. If you have questions on factoring, always make sure you get with me. X minus 7 will cancel, leaving a 1 in the numerator. And that's 1 over x plus 4. So make sure we're good before we do another one. All right, so 3x plus 6 over x minus 6 plus x minus 30 over x minus 6. Denominators are the same, so we can go ahead and combine the like terms. 3x plus x is 4x. 6 and negative 30 is negative 24. Factor the 4 out of the numerator. You're left with x minus 6. X minus 6 over x minus 6 will cancel, leaving you with 4 over 1, which is just 4. All right, questions? All right, so the next one, they're trying to set you up for adding and subtracting the fractions or the rational expressions when you do not have common denominators. So you need to find your LCD, least common denominator. So when we look at what we have here, we have x plus 4, x squared plus 2x minus 8, and we want to know what is the LCD. So you want to examine each denominator, factor them out completely. There's nothing you can do with x plus 4, but you can factor out x squared plus 2x minus 8. That's going to be x plus 4, x minus 2. So what you would do is take the highest power of each quantity that's being represented. There are no powers here, so there's nothing to write down but what we see. But you don't write down anything repeated. So notice we have x plus 4 here and x plus 4 here. I would not write x plus 4 twice if I want to write the LCD. So all I would do is when I run across x plus 4, that would be my first quantity or first representation of x plus 4. Then my next term or next quantity will be x minus 2. So the LCD is x plus 4 times x minus 2. Once again, you do not write down the x plus 4 twice. At least not if you want the least common denominator. All right, next one, 4a over a minus 3, a plus 10 over a squared minus 9, a minus 3, a squared minus 9. That factors out to a plus 3, a minus 3. So my LCD will be a minus 3, a plus 3. And as I mentioned before, we already have a minus 3, so we don't have to write it a second time. All right, so we have x minus 8 and 8 minus x as our denominators. If I were to rearrange my terms here, that's negative x plus 8, in which each one of my terms are opposite signs. So if I were to multiply, let me do it like this. So when you have opposite signs, we can multiply that by -1. And that will give us that same denominator that we have over here. So that's what we would do if we were trying to combine them. We would just multiply top and bottom by -1. So that means my LCD is just x minus 8. You just have to make sure you have opposite signs of each term. All right, questions. All right, another type of problem in this 7.3. All right, so we want to fill in the blank to make it an equivalent fraction. So what you have to do is ask yourself, what times AB will give me 9a squared b to the fifth? So how do you get from one denominator to the next? And the one way you could do it is take 9a squared b to the fifth divided by AB. It's going to be 9a b to the fourth. You subtract your exponents. So you multiply that to the negative 7. Maybe I should have my arrow going the other way. Because basically what you're saying is you will multiply top and bottom of that first fraction by 9ab to the fourth. So negative 7 times 9 is negative 63 ab to the fourth. And then that'll be 9a squared b to the fifth. So this is what goes in that box. Negative 63a b to the fourth. All right, next one, same type of deal. You look at what you have and look at what you don't have. We're trying to get this denominator to look like this denominator. You notice that we have two x minus 3. What we do not have is this x and this x plus 9. So what you're saying is that 2x was being multiplied by x times x plus 9 to the top and bottom. You know, like I said, those were the missing pieces. We have x here and x plus 9 here are missing when you look at the first denominator. All right. Make sure we're okay with that. So that bottom denominator is x times 2x x plus 9. This numerator, I'll do 2x times x, which is 2x squared. And then distribute the 2x squared. So it's 2x cubed plus 18x squared. All right. Questions? Do one more like that. So you have t over t plus 9 be equal to, we have the box, and then t squared plus 7t minus 18. Once again, you want to know what is the difference between the two denominators. When I look at t squared plus 7t minus 18, factor that out, that is t plus 9, t minus 2. So the difference is this t minus 2. So it means I'm multiplying both top and bottom, numerator and denominator, by that t minus 2. So that'd be t squared minus 2t. That's in the box. All right, questions before we do a few more problems? Let's see the next one. All right, so we have 3 over 7x squared y minus 1 over 21 y. So we need common denominators. And we need need to figure out what the LCD is between the both of them. All right. So when I look at this breakdown, I can't break down 7 any. That's x squared y. When I look at 21, that's 3 times 7 times x times y. So just like when we're dealing with the expressions, you want to take the highest representation that you see of each number. So that 7 is what we'll take. Whatever your highest exponent is, we'll take over variables. And then we'll take 3. We don't need to write 7 again. We don't need x and we don't need y because we already have them. All right, questions on that? If I had an 11 back here, then I would have 11 as a part of my LCD. Or if I had factored out and had 3 squared here, then I would choose 3 squared. So you always want to choose the highest power of your factored terms, or the highest power of your factors. So 3 times 7 is 21. That's x squared y. So this is the term that we want to turn both of these denominators into. Need more room. So I want both my denominators to be 21x squared y. So you say what times 7x squared y will give you 21x squared y? And it was just 3. So you multiply both top and bottom by 3. So it'll be 9 for my first numerator. Then you have 21xy. Said what times 21xy will give you 21x squared y? And it's just x. And so negative 1 times x would be negative x. Now I can finish off the problem. That's 9 minus x over 21x squared y. All right, questions? Any questions? All right, so here we have x minus 2 over x minus 4. 2x squared minus 15x plus 12 over x squared minus 16. So once again, looking at these denominators, we need them to be the same in order to add them up. So one of them is x minus 4, the other one is x plus 4x minus 4. So that means my LCD is going to be x plus 4x minus 4. We just don't write the x minus 4 twice. So that means I'm multiplying top and bottom of that first one by x plus 4. We know that second denominator is x minus 4, x plus 4. So we don't have to change that one at all. All right, questions before we keep going? Make sure we're all right. And of course, all I did was, factor and left it like that. That's all. As far as that second denominator is concerned. So now go ahead and distribute. So we'll be able to combine our like terms. So that's x squared plus 4x negative 2x minus 8. As a matter of fact, let me do this. I just wanted to go ahead and fold that out. So that's that. So now let's go ahead and make it all one fraction. Combine the like terms. That's 3x squared minus 13x plus 4. And we have to ask ourselves, can we factor this out? I think we can. Let me see if I do 3x. So 3xx, that'll be 12x, 1. Yep, that'll do it. So that factors out to 3x minus 1 times x minus 4. X minus 4s will cancel. And that'll be 3x minus 1 over x plus 4. All right, let's do a few more. That's minus. All right, so next one, oh, that's not b plus, that's b minus 3. over b squared minus 16 minus b over b squared plus 10b plus 24. So factor out your denominators to see what you're working with. All right, so we have b plus 4, b minus 4 from the first factorization. Then from the second factorization, b plus 4 times b plus 6. So that means our LCD is going to be b plus 4, b minus 4, and b plus 6. You write down each different quantity. All right, so I rewrote the original problem with the factored denominators so we can clearly see or see cleanly even what the LCD has and what we do not have in our denominators. So when I look at my first denominator, I have b plus 4, b minus 4. I do not have b plus 6. So I'm going to multiply top and bottom by b plus 6. Looking at the second denominator, I have b plus 4 and b plus 6. I do not have b minus 4. So I'll multiply top and bottom by b minus 4. All right. So that's b minus 3 times b plus 6 minus b times b minus 4. And that's all over the same denominator, b plus 4, b minus 4, b plus 6. So before we expand and combine our like terms, questions on what we've done. All right. Distribute and distribute this negative b. So that's b squared, 6b, negative 3b, negative 18, negative b squared plus 4b. All right. So our b squared minus b squared actually cancels. Then we have 6b minus 3b, which is 3b, plus 4b, so that's 7b. Then that minus 18 back there, can't combine with anything. And that's over b plus 4, b minus 4, b plus 6. And that look like that is it. That was 3 times 18. Yep. Can't factor out anything from that numerator. So that is it. All right. Questions? Any questions? All right, let's do this one more. X minus 9 plus 1 over x plus 9. So just like when you have regular fractions, you're trying to add them to a regular number. We got, regular fractions, we're trying to add them to just an integer or regular number. A number without a denominator is always assumed that you know there's a 1 under there. So x minus 9 has a denominator of 1. And if that's the case, I can multiply both top and bottom by the LCD of x plus 9. Pull that out, that'll be x squared plus 9x minus 9x minus 81. X plus 9. These cancel. 9x minus 9x. And then you have negative 81 and a positive 1. So it's x squared minus 80 over x plus 9. And that is it. Questions on that? Questions on anything I've said, any problems I've done today?
Professor,
Yes, sir.
I'm gonna be honest with you. I'm writing all the examples down. I won't be able to really ask legitimate questions until I get into it in the book.
Right. I understand that. Yep.
Right now, I'm just writing the stuff down. I probably other students the same way, just writing it down. But how to do it, I probably don't know how to do it until I get into the book.
But that's how it works sometimes. You got to go and take what we've done and apply it. The problem is that sometimes people wait too long to actually, try the stuff out. And sometimes it'll be like you never sat in class if you wait too long to try these things out. So the thing is that you get into the lecture, absorb as much as you can, then try to do this stuff within the next day or so, and then see what questions come up. You really won't know what legitimate questions you have until you actually try the stuff out. But there may have been some things that I've said that may have, they'd be like, hey man, can you re-say that? Or something. That's when I say on a new lecture, when I say, do you have any questions? I'm talking about like, do you want me to repeat something? Or was there something that's just like, whoa, go back? You know what I mean? Something like that. But if you're just talking about conceptual or trying the problems out, yeah, some questions aren't going to come up till you actually try. Yeah.
I got a question. If we have a problem doing the homework, do you have like office hours if we need to contact you?
Yeah. Email me. That's what I always say. Email me and we can set up office hours. That's what I've been doing with I don't know if anybody in this class have done it, but plenty of my other classes, what they do is they email me and we set up, okay, when are you free? This is when I can do it, and then we just match up schedules.
Gotcha.
And then once we do that, I'll shoot you a Zoom link. Just like I have to meet with somebody this evening, you know.
Yeah, it's got real now.
Yep. So when you have some times, if you know for a fact that you want to meet and you have some times in mind, shoot me an email with those times and days. And then if I can make that, then I'll make it. And give me more than one, option or something like that. So if I can't make your first option, I can shoot for your second or whatever. And then we'll go from there. Once you
Thank you,
respond to
Professor
that,
Tucker.
I'll shoot you a Zoom link and then we'll meet up.
I see. I'm gonna need help with this.
All right. Not a problem, sir. Not a
There's a lot of
problem.
steps.
Say the last part again?
There's a lot of steps. You have to do a lot of steps.
Yeah. Yep.
One problem
Yep.
takes up a page.
Most definitely have to stay and stay focused. It's easy to miss a sign or miss a term here and there. Yep. All right. Anything else or anybody else before we close? Good, everybody straight?
Thank you, Professor Tucker.
Yeah, no problem, no problem. So, you guys have a good one. What's today? Tuesday. So I'll see you on Thursday. Once again, my doors are open. Shoot me an email if you need me, and we'll go from there.
I'll be honest with you. I'm probably gonna be firing off an email. Trying to schedule a time for Zoom.
Okay. Sounds good.
Thank you, Professor Tucker.
All right, no problem, man. Take care.
Have a good one over here.
All right, you do the same, sir.
Yeah.